this morning for this webinar. My name is Richmond. I'm Business Development Manager for Park Signalling. I'm here today to talk to you a little bit about our company, a little bit about signalling, and about two specific products that we have that can actually help you in your day-to-day operation of SSI signalling systems. We are open to questions. You'll see you've got a question line on the webinar screen. Please feel free to raise any question during the webinar, and I'll attempt to answer them at the end. If there are any questions that I can't actually ask or answer at that time, we can always get back to you if you leave your details. Okay, without further ado, we'll press on. So I'll start off with looking at Park Signalling and who we are. Really, Park Signalling, what we try and do is deliver engineered solutions for radio signalling, telecommunications, all these kind of systems, industrial control systems, those kind of things throughout the world. We've got staff, I believe, at the moment of 26 full-time staff who are predominantly engineers who are very, very high and experts in their field. And we have a number of part-time associates and other additional staff that we can call on when necessary. So what that means is we can be quite flexible in taking on workloads, so we can flex the size of the company to meet the opportunities that are out there. Predominantly, we've been based looking at SSI signaling systems, but we have a lot of experience in other areas such as low-cost signaling systems, ERTMS and ETCS. So a little bit of background and history there. The company was formed in 2000 by key staff from Manchester office of Alstom Signalling when that closed down. What we like to pride ourselves on is the knowledge and experience we have and the way that we look at trying to solve problems for people. We like to innovate wherever we can, using the knowledge of all the engineers that are within the company and try and provide a tailored solution to meet and exceed customer expectation. So what we can do is we can focus in on what problems you have and give you a tailored solution to actually get rid of that problem for you. Now, Park had operated for 16 years, whereupon we were taken over by Unipart Rail. And we've been part of that group since 2016. What that's meant for Park is it's given us access to funding, to centralised resourcing, and has really helped us to actually expand the business. We've trebled the size of the business in that time. So just briefly, what we do, we separate ourselves into three areas, really, what we do: services, products, and systems. So it's pretty much self-explanatory. I don't propose to go through all the elements on those slides. If you have a look on our website, park-signalling.co.uk, then you'll find a lot more information on there on the specific products, experience of things that we've done, and really what we can offer for you. Just very briefly here, we'll look at some of the products that we do. You may or may not be familiar with a lot of these. The approved products there are mainly to do with servicing SSI equipment, monitoring SSI equipment, and actually help you improve fault finding, productivity, reliability, all those kind of things. We are experienced in developing products with Network Rail, so we have a number of ongoing projects there which are still developing products. And we also look at innovative solutions, so we look at new technologies and how we can actually use them to produce low-cost, robust signalling systems and control systems for the industry. So moving on, let's talk about signalling and the equipment we could go on there. And very basically, I know probably a lot of you there on the call know far more than I do about this, but this is a definition I found of interlocking. Maybe not the best or the worst definition out there, but really it gives you an idea of what an interlocking is. That's the very core of the signalling system here. So it's really to make sure that trains can only proceed when a certain number of criteria have been fulfilled. And that means that the trains can operate safely without coming into conflict with other rail movements. So, looking back in history, we traditionally had a number of ways of signalling. It started off with policemen, hence the reason that signalmen are known as bobbies. Then further signalling systems were developed as accidents happened over the year, and then technology improved. So really, the three key ones we're going to look at today briefly, and then more in depth later on the electronic side, is we'll run through briefly what mechanical interlocking is, a relay-based interlocking, and electronic SSI interlocking. As I say, very briefly, for well over 100 years, probably more like 130, 140 years, these mechanical interlockings were developed to control train movements out on the railway network. I believe the first one was introduced in the early mid-1840s. It's an example of a box here on a preserve railway at the moment at Roseley on the left, and on the right you can actually see the mechanical side happens underneath the interlocking. So what you have obviously in the signal box, the picture on the left is where you have a signaller, where they can look and see what's around them, and they have a box with various levers, control points, control signals, and that kind of thing, facing point locks, all those kind of things. So that's a very good system, very safe system, but it has its limitations in the distances that you can actually operate over, because it really needs to be inside of what the signaller can see, and also the expense and size of the equipment. So on the right there, you'll see mechanical interlocking, which would normally sit below a box. That's a large interlocking for one of the bigger boxes out there. But as you can see, it's quite bulky, and you're limited in the amount of apparatus that you can operate with that. So over the years, technology improved and developed into a relay-based signalling interlocking. So this is enable, panel sizes to actually physical sizes to be reduced, but actually control areas where you can operate over, signal box operator over, could increase. So this is powered electrically, and it means that you're no longer limited by cable lengths and things like that for how much a signaller can actually pull a physical lever. So this form of relay-based interlocking was in use for a long time and is still in place in certain areas. So as time developed in the 1980s, first form of electronic signalling was looked into. It was developed by British Rail Research, GEC as was, and Westinghouse under a tripartite agreement. Now this system was known as SSI, which is solid state interlocking. So what this does, it uses electronics rather than electromechanical relays. The same interlocking rules or control equations are used as in the relay-based interlockings, and they form the basis of this technology. So what happens with this is, the reason this has been able to make things a lot smaller is that the relays that used to form the circuits are replaced with software variables, and actually the only relays you then need are the ones at the final output for the equipment that's being driven. So a computer processor evaluates where the virtual relays are within the software and uses the same interlocking equations in digitized form, and the control rules are modified to software algorithms stored in the memory of the system. So that really gives you an idea of what an interlocking does. It's moved the system on from obviously a much larger mechanical system, semi-mechanical system, and now a mainly electronic system. So just to go through the process here, the principles behind the SSI interlocking use a 2 out of 3 redundancy architecture, whereby all safety critical functions are performed in 3 separate processing lanes, and the results are voted on. So an SSI interlocking cubicle comprises of 3 interlocking processors, or multi-process processor modules, MPMs, and 2 panel processors and a diagnostic processor module. So an SSI system runs on a 2 out of 3, so you can operate with 2 MPMs running. If the third one fails, the system can still work. So what we've got here is some examples of SSI hardware, the external hardware you find out there in the cabinets blindside and in the signalling centres. So you can split it down into a number of modules there. What you have trackside functional modules, which are controlling things such as points or signals, and the centre picture there shows you examples of those. So the points module is on the left, coloured black, and the signal module is on the right, coloured red. So trackside equipments are connected to nearby TFMs, trackside functional modules, and each module has a number of outputs and inputs. So each of those outputs drives an individual function. That could be, for example, a signal lamp, and the inputs on the module are used to send information back to the interlocking, such as indications determined by a track circuit relay or point detection circuits. So that's actually transmitted over a twisted pair of copper cables. which then take the information as telegrams to and from the interlocking. So that's how it's controlled. The two routes are diverse, so you can operate with one data link operating, use that method of redundancy in there. So the communication between the interlockings and the TFMs is by electronic data known as telegrams. So these are transmitted on the data links and the data I mentioned to keep the reliability there. The data link module is interfaced between the data link and the trackside functional modules. You can see examples of those on the right-hand side of the picture there. So why SSI? What advantages does that have over the relay-based signalling interlocking? Well, there's a number of options, a number of advantages on there. It's much more space efficient. You don't need as much real estate to actually house the equipment on there. The entire logic circuits are simulated in software, so that means that you can actually control it, you can verify it, you can look and make sure that everything's safe and update as and when necessary. It reduces the cost compared to relay-based interlockings for the cost of relays themselves and the wiring in between them. It can be much quicker to install and overall maintenance costs are lower. Also there you've got the additional safety elements here that the software is verified, validated and documented. So here at Signaling, we've looked at how SSI's data links and equipment operates and looked in ways that we can try and help technicians and faulters go out there when there may be a problem or they need to monitor some equipment. So one thing we've developed here is our SSI Link Analyser. So hopefully a lot of you may be familiar with that. So what it actually does is it actually detects Manchester coding errors, parity errors, missing telegrams and glitches. So if a coding or parity error is detected, the data contained in the telegram will be deemed as invalid and it will be discarded. So this will also cause a missing telegram to be logged in addition to the coding or the parity error. So if a telegram is missing, for example, or its timing bits have been corrupted, it will be reported logged as missing. Data and status state display will be cleared until a valid telegram is received again. So that's what it does. It enables you to actually look into the health of the data link and actually record and log that information. So the SLA there is comprised of a number of modules. We'll go through those shortly. But first of all, we'll just go through some of the extra features that you can use with the SLA. So you can use it for logging. It provides time-stamped logging events onto the laptop computer there. Time is based on the PC's internal clock and has a resolution of 10 microseconds. It can look for detect erroneous telegrams. It can look for missing telegrams, it can look for glitches. You can look at all the valid telegrams and look at telegram changes on there. So you can configure what you're looking at through the software on the SLA to actually look and try and detect the issues that you're looking for. So what you can do there also, you can actually have a trigger module. So the actual core of the system there is the master module, the optical fiber, the test point adapter and the laptop PC. If you add the trigger module and the peripheral power lead on there, it can connect and trigger ancillary test equipment such as an oscilloscope. So as I mentioned before, there are a number of elements on there, a number of components making up the SLA. So first of all, there on the left-hand side, you've got the laptop PC and software. So that's used to, the laptop's used to run the SSI Link Analyser user interface software. The ST101 master module you'll see there is really the core of the system. That's actually what drives it and what enables us to do what we need to do here. So it performs the low-level decoding of telegrams from the data link and passes that to the PC. It doesn't need external power, it's powered directly from the PC it's connected to. So the optical fiber there, as you can see, the ST110 is actually provides a connection between the master module and the test point adapter, which is 112. Now this is another real key feature of the system here. So what it does, by using an optical fiber, it gives a robust electrical isolation between the signaling system that you're connecting through the test points and the SLA, the analyzer itself. So they're electrically isolated from each other by passing through the optical data point. So that's key to this system. You're not interfering with the data on the telegrams there. So what you've also got on there as well is a test point adapter. As I mentioned before, that actually converts that into the optical fiber. There are additional items you can have on this to increase the functionality if you wish. So first of all, you've got the trigger module. So that means you can connect it to a trigger test equipment, such as an oscilloscope. So you can also mount things on there like telegram patterns. And if you have that, then you have a peripheral power lead, which connects a PC to that module there. So that provides the power for it, so you don't need an additional power source. So that really gives you an update of the equipment that's involved there on the SSI. Now that looks at one side of the equation here. But then we also have developed a product called REMOSd for the recording and monitoring of SSI data links. Now again, probably a lot of you might be familiar with this product. You can see it there. It comes self-contained with a paddy case, so you can take it out quite comfortably line side, plug it into the test points on your trackside functional modules, etc., and actually use it there to drill down into the information and actually use it for faulting purposes. So the data links themselves are very reliable, but they can be difficult to fault find, particularly when there's multiple faults present there. Maintenance regimes require that SSI data links are tested on a regular basis, and this can be expensive and time consuming if you have to go out there and test every single module that's out there. What we did with REMOSd is we developed a tool to monitor the links and provide faulting assistance when you get data link problems. This has led, hopefully, and the evidence says that it has achieved this, faster restoration of the data links. So it's a standalone and portable system, and it basically works by eavesdropping on the data link in order to monitor and report performance changes. As you can see from the diagram there, it actually connects again through the banana cable, or the cables there, to the test points to have a look at. So obviously you have the REMOSd system there. What does it actually do? What does it enable you to do as a technician going out there line side? Well, the first thing it does, it enables you to examine and log various parameters to do with the telegrams. So these include such things as the major and minor cycle timing, telegram statistics, and the delta timing. Now the software comes on the main REMOSd system, enables you to measure things such as peak-to-peak amplitude of telegrams, symmetry, the overshoot, amplitude variation, and it can also check the noise between telegrams. So it actually gives you a lot of functionality out there, and that's as the product was developed. We're since in consultation with people out there using the equipment, and what we've looked at internally within the company, we've thought of some additional functionality that we could do on there, and that led us to develop the viewer software. Now, if you buy a REMOSd system, you can have it with the viewer software, and we do recommend that that's how you buy the system on there, because it gives you the full functionality then. So what that enables you to do, you can further analyze the telegram data, and it incorporates an on-screen measuring tool which enables measurement of time and voltage differences. So what this does, the viewer then enables users to create reply bar plots, major and minor cycle timing tables, delta timing tables, and delta link line plot plates. So that's additional functionality from the same data that you're gathering by putting into the system there. So with all this functionality, it means that the REMOSd enables an engineer to conduct detailed analysis of data link performance in relation to any complex situations or fault situations you might have out there. It gives a very unique capability for displaying visual performance and waveform characteristics, which you can see there with the incorporated picoscope. And really, it means that you can look at really improving the performance of your equipment out there on the data link, getting it running optimally and doing things as quickly as possible. Just for example, on here we've got some screens showing some of the screenshots from REMOSd. On the left-hand side, can see the main screen, which you'll get when you actually log on to the system, giving you the options of what you can do there. And the other two pictures showing some of the functionality that we actually have on the system there, including on the right-hand side of Picoscope. What we can do with the REMOS and the SLA is offer a combined unit. So that's known as REMOS SLA Combi. And what you get then there is all in one box, in the same case, you get REMOS in, you get SLA functionality on there with the software on the laptop as well. So that means really you've got a one-box solution there for going out and monitoring and faulting on SSI data link and trackside functional modules. Okay, I think that's really everything I wanted to go through today to look at that. Hopefully that's been interesting, and hopefully you can have any questions that you may want to raise on that. Please feel free. If there are no questions at this point as well, then what we can do, if you want to email us info@signalling.co.uk, then we can answer any questions that you have offline there. Okay, so I'll just have a look through and see if any questions are here at this stage. Just bear with me one moment while we do that. So I've had one question here coming asking what a glitch is. Okay, so a glitch in effect is it's a high to low transition on a data link that's not part of the complete telegram. Any more detail than that, I have to get back to you with more information on that if that's what's needed. Okay, well, thank you very much, everyone, for attending today. We do have a number of other webinars planned, which will look into other elements of the equipment. But I'd like you to please go on to park-signalling.co.uk to find out more information, and there as well you'll be able to download data sheets on both of these products today. Thank you for your attention, and goodbye.